Alrighty, so we've got 3 goals for the day. First one, define and identify arithmetic sequences. Second one, write explicit formulas for arithmetic sequences. And the last one, evaluate arithmetic series. So let's start off with a definition for an arithmetic sequence. So an arithmetic sequence is a sequence in which, there is a constant difference between terms. So when we're saying constant difference, that means we're either adding the same value over and over and over again, or we're subtracting the same value over and over and again. So this is very comparable to a linear function, where you're just going up or going down at a constant slope. So let's take a look at a couple of potential examples to determine whether they are or are not. So this first one, it goes -10, -4, 2, 8. Looking at this pattern, we're adding 6 every time, kind of going back to how we approach things with like first and second differences. This one's, it's not like super imperative that we go and like identify what it is each individual step. If you can just see it, it's fine. We'll just say, yes, it's arithmetic, and I'm also going to introduce this new letter D, which stands for difference. The difference is 6. The second one, 11/2, 11/3, 11/4, 11/5, 11/6. While there is a clear pattern to that, the denominators are increasing by 1, we're not just adding the same whole value each time. You're adding 1 to your denominator, but we're not adding the same fraction over and over. So we're just going to say no to this one. Last one, we got -2, -5, -11, -20, -32. Again, this one there's another clear pattern, so like this one's -3, -6, -9, -12. The second differences are constant, but that doesn't make that, the first differences aren't, so it's not going to be like a linear function, so we're just going to say no. It's not similar to a linear function, nor is it going to be an arithmetic sequence. Here's a general rule. We talked about how to write some arithmetic, or how to write just explicit rules for certain sequences. This one's going to be kind of the pattern we're going to use for arithmetic sequences. So the nth term, a sub n, of an arithmetic sequence is given by this equation. A sub n equals a sub 1 plus n minus 1 times d. Sometimes I'll see people write it like this, and this is acceptable as well. A sub 1 plus d times n minus 1. Some people like thinking about it that way. So a sub 1 is the first term, and d is the common difference. Now with that in mind, let's try out this example right here. We're asked to find the 11th term of this arithmetic sequence. So looking at the pattern here, we're subtracting 2 from each of these. So we're going to say our d value is -2. Kind of got ahead of myself. Probably should write the whole equation. A sub n equals a sub 1 plus n minus 1 times d. We're going to try to fill in as much as we can. So we found our common difference is -2. N is the number, kind of like your place in line that we're trying to find. We're trying to find the 11th term, so we're going to plug in 11 wherever we saw n. And a sub 1 is the first term in that sequence, and in this case it's -3. So let's plug in what we know. We've got a sub 11 equals, now we know a sub 1 is -3, plus 11 minus 1, so replace that n with 11 as well, times -2. Now if you're putting the d after that n minus 1, definitely important for you to put it in parentheses, or make sure you're indicating that it's multiplied by -2. Otherwise, if you just put a -2 after it, it might look like you're subtracting 2, so be careful with that. Let's clean this up a little bit. We got a sub 11 equals -3 plus 11 minus 1 is 10 times -2. So we got a sub 11 equals -3 plus 10 times -2 is -20. When we add those two together, we get a sub 11 equals -23. And so that is our 11th term. For example 3, I'd like you to, oh, never mind, I'm getting ahead of myself again. This one, we've got some sequence here with some blanks in it, and we got to figure out the missing terms. So we're kind of looking at a pattern here, a couple different ways we can go about this. Probably the most straightforward way is, okay, well, we've got this 17 here. And each of these blanks that I have here, sorry, my mouse is there. Each of these blanks that we have here just means we got another term. So we're missing these 3 terms. So to get from the 17th term, we got to go 1 term, 2 terms, 3 terms, 4 terms. So this is our first term. This is our 5th term here. And we're looking for a sub 2, a sub 3, a sub 4, a sub 5, etc. One way we can go about this is if we say a sub n equals a sub 1 plus n minus 1 times our common difference d, we can figure out a lot of these. We know our first term. Our first term in this case is 17. N would just be kind of like the number of the term that's our last in line. So we have our 5th term, so we're going to say it's 5. What we don't know is the common difference. That's what we're going to have to figure out. So let's plug in what we know. Let me zoom in a little bit. Sorry, I didn't realize I was that far zoomed out. So let's plug in some of the stuff we know. So a sub n, though that's going to be a sub 5. We'll replace that in a second. A sub 1, we got 17 plus n, we said was 5, minus 1 times our common difference d. We don't know d yet. That's what we're trying to solve. Cleaning this up a little bit, a sub 5 happened to be, well, that negative 7 that we had at the end, equals 17 plus 5 minus 1 is 4, so we got 4 times d, or 4d. Not 4t, but 4d. Cleaning this up, trying to solve for the common difference, we got, let's subtract 17 from both sides here. Sorry, let me switch colors a second. Let's subtract 17 from both sides. So negative 7 minus 17 is negative 24 equals 4d. To keep solving for that common difference d, we got to divide both sides by 4, and we get negative 6 equals d. So that's our d value. Now what you could do is you could go through and plug in n equals 2 to find that second term, n equals 3, n equals 4 to find that second, third, and fourth term. Or instead, if you know the common difference is negative 6, we can just take this and subtract 6 over and over. Sorry, let me switch colors again. I'll go to the red. So we subtract 6 from there, subtract 6 from there, subtract 6 from there, and just to double check, make sure it goes to the last term, we'll subtract 6. So 17 minus 6 is 11. Minus 6 from that is 5. Subtract 6 more from that, negative 1. Subtract 6 from that gets us to that negative 7. Exactly what we were looking for. Another way you can approach this is you're looking at, to figure out the change, common difference, it's your overall change divided by your number of, and I'm going to use the word steps here. Let me rewrite this because my 2 L's there look like the 4. So it's your overall change divided by your total number of steps. So that means going from your first term to your last term. So going from going from 17 down to negative 7, we went down by 24 over a period of 4 steps, which gives us that change of negative 6. And again, once we have the d value, we can go through and use that to find each of the next terms. What I'd like you to do is take a few moments using that skill. Try example 4, please. And I'll continue that in the next video.